Hello guys. In this video series playlist, we are going to solve some marathon problems on the tree, mostly on the medium and the hard level. Our aim will be to build the intuition and have some follow-up questions on the famous patterns. So there are some prerequisites I would assume that you already got the idea around in the trees regarding the basics like what exactly is a binary tree, how many node it might be having, the basic traversals like the in order, pre-order, post-order, and the stuffs like the DFS or BFS, like how exactly I do a recursive DFS traversal, or how do I go in a BFS manner. So if you are not very confident around that you might need to revisit them time to time while I solve few of the problems, because this concepts will be used heavily around the problems that we are going to solve. So here we are going to cover a pattern of, like in this particular video, we are going to cover a pattern of determining the height and solve a follow-up questions with that pattern. So let's start with the first problem, that is determining the height of a binary tree. So let's talk about the definition, like what exactly the height of a binary tree. So by definition, the height of a binary tree is nothing but the number of the edges on the longest path from the root node to any leaf node. So over here, if you see this particular example, what exactly is the root node here? So the root node is this one, right? Our one is our root node. And from the root node, we can keep on determining the different length. For example, here is one edge and here is one edge to the leaf node of 4. So what exactly is the height of this? So if I treat this 1, and if the height of this is again 1, so total it will be 2, right? 1 plus 1. So there are 2 edges. In this path there are 3 edges till 7, and also in this path there are 2 edges. So I would request you to just take a pause and take any example trees and try to determine what exactly is the height of the tree. So for example, here you can see like height of till 4 is 2. Like this path, if I take 1 to 2 to 4, like this one, from here to here, this path, this particular path, the height over here is 2. Okay, and then there is another path, 1 2 3 to 5. If I take this particular path, right? So here what would happen is this part is already 1, and this is the next part, that is also 1. That means like 1 plus 1, it will be 2. And then there is another path, that is 1 to 3 to 6 to 7. So in this case, the height is 3. So I hope you get the idea that among this 3, what exactly is the height. So height is the number of edges of the longest path. So longest path is definitely this one, which have 3 edges in its route. So for this particular tree, if I have to say, the height is equal to 3. So now the problem, we have kind of grounded and got the idea what exactly is happening around a tree to get its height, right? The longest traversal to the leaf node. But now we after taking on the basic of the problem, let's try to answer few questions and divide it into the sub problems. So if I ask you this particular question, that you are standing at the root, now you can't really see the whole tree, right? Like there is no method right now in the binary tree traversal where we can see the whole tree. If I see the binary tree data structure, I can only see the left and the right node. So if you can't see the whole tree, so if someone comes from the left side or the right side and tells you that, look man, I have the height of X and my left subtree or like the right subtree comes and tells you that I have the height of x, and the left subtree comes and tells you that I have the height of y, how would you use these two numbers to figure out your own tree's height? So let's take our example in this. Suppose I am standing over here in the 6. So 6 only have a single node. It doesn't have two node. So suppose this is like my right node, and what would happen over here is, so from the left node we will get no numbers, right? We will get probably something like 0 from here, and from this node we are going to get something like, from 7 we are going to get something like 1. So how are we going to use this information? Now if you see that in case I am standing at the 6, my aim is to find the height of the 6. So what would be the height of the 6 here? It will be the max of both of these numbers. Like if it is coming from the left edges and the right edges, so in the left side there are 0 edges, and in the right side there is 1 edges. So what would be my actual height of this? My height will be 1. So we can further refine it in a way that, like, while writing the code we will refine it more, but probably you get the idea that in the 6 right now, for this one, for 6 it is 1. Okay, now coming about 5. So in 5, again I do not have anything. So for 5, what would be the height of it? For the 5 it will be 0. Now when both of these things come there at the top, there will be one more edge will be added while we will be evaluating 3. So now if we go to the number 3, what it will exactly evaluate? It will evaluate this one and this one. So now I already have 1 from this side and 0 from this side. Alongside this, here 1 will be added because one more edge is there, and also here 1 will be added. So over here the height of this will be max of the left height, because the left height is right now 1, and the right height is basically 1 plus 1. Like you see, already one edge was there and the next edge is coming up. So I have 1 and there is 2, right? So from the right side there is 2 and from the left side there is 1. So the height that is coming is 2 at this level. So similarly, if we calculate the height of the 2, the height of the 2 over here is, over here you can see only a single edge is there. So if I go bottom up, the height of this will be 1. So now what is happening is, when I'm returning to this level, okay, while I'm returning to here and I'm returning to here, I already have 2 and here I have 1. So what exactly I'm returning over here? This number 1 I'll be taking and I'll be returning to here, and this number 2 I'll be taking and I'll be returning to here. Okay. Alongside this, this particular edge will also be added. So for 1, what will happen is, from the left side it will be 1 plus 1, because this existing edge will also be added, and for here it will be 2 plus 1. Okay, so out of these two things, what do I have? Max of 2 comma 3, it is becoming as 3. So now you see we have solved the problem in a bottom up approach. Like there was no direct way to solve this, because from the root we do not have any visibility towards my complete height. But from where do I have the visibility? I have the visibility from the leaf onwards. So the advantage that I have had here is to traverse from bottom to top. And from traversing to bottom to top, what I did, I kept on taking it from the bottom level and I went till the top. And how we will write the code, we will come into that. But before that, let's tackle some of the other fundamentals and the edge cases so that we understand the, before writing, we understand the fundamentals more deeply. So let's tackle this edge case, that when there is only a single node, what would be the height of it? So if I see in the single node, there is the height is have to calculate it by the number of edges till the leaf node. So what are the number of edges till the leaf node here? There is no edge, right? So the height would be 0, because this is it, this itself is the leaf and this itself is the root. Now coming to only a single child node, like here I have this root and I have this as a leaf. So what would be the height of it? So definitely there is a one single edge and the height would be 1. So one of the critical point regarding this calculation is, so when we are returning this particular leaf node or a single node, how we, it will be better to calculate is, treat this node as what would be, what would be its height. So if I see the height of this leaf node, so again I'm now gradually going into the how we are going to write our code. For this the height will be 0, right? And if I do have any child, then what I'm going to do is I'm going to plus 1 with that. What I mean to say, that whatever that is coming from the leaf node, I'm going to return their height, and we are going to do a plus 1 with the height of the maximum of both the child. So instead of leaf, I can also say that it is a child node as well. So this doesn't have any child, right? Like 2 is completely a childless node. So what this 2 would return is, this 2 would return -1 if there is no child. And while calculating it, how we are going to calculate this height is, we're going to calculate as 1 plus max of -1 comma -1, which will come as 0. So in our recursive condition, like as you can see over there, if we have to go bottom up, the only way we could go till the depth is through recursion. In our recursive condition, this is an important point. In our recursion, we are going to return null node as height -1. So this is one of the very basic, or the exit condition that we are going to consider over here, that if there is no node, like if there is a single node, then height is 0. Now the point that I'm trying to make is, if it is a null node, the height is going to be -1. So what is the advantage of it? In case the height is a -1, like treating the height as a -1, we are going to add this particular add 1 in our formula, like whatever the max that is coming from the child nodes of a given node, we are going to add 1. With this formula, you will always see that we are getting the right height. Otherwise, handling this condition of null will be really difficult if we keep on returning 0. So over here also you can see the height is 1. How it is calculated? So it is basically the max of 1 plus the max of, the left is, here it is null, so -1, but from here it is coming as null, right? So it will be -1, but here it is returning 1. this guy is returning 0, 2. 2 will be returning 0. So I am having the max of -1 and 0, which will eventually be calculated to 1. And we are getting the height of the resultant height of the child node as 1. So this child node height is basically 1 now. Okay. So I hope you get the idea that how exactly we are making the calculation. So let's try to write our code. So to solve it, I have already covered a basic solution, or just so that you don't see me writing all the codes from the basic level. And what we will do is we will try to debug it through how we will do for any given application in a real world scenario. And also we will try to trace out the complete end-to-end recursion tree. That will be the core of our learning. So uh, I will just give you a little idea of what I have done over here. So there is a basic node data structure that I have created. In that data structure, the node will take the value that we pass, and it will be the left and the right will be the null by default. And that node I'll be using in my binary tree. So a binary tree will have multiple nodes and they will be connected with each other. And also I have created one test folder. What this test does is this test keep on running many inputs on top of the on top of the code that I'm going to write for the binary tree. And based on all these things, we will be able to debug it through. So now, as you can see over here, I have written a class of binary tree and I'm trying to get the height of it. Okay. So if you remember the first or the exit condition that we write, the exit condition over here will be if node is none, then we are going to return -1. Okay. After that, we are going to determine what exactly is my left height and the right height. So because this is a recursive call, so let's determine our left height at first. So our left height would be height of node dot left, and our right height would be, we are going to pass in our height the node dot right. In case this recursion is not very clear to you, once we trace out the complete recursion, you will get the full idea. Okay. So after that, if I just go back to my Excalibur, you remember this is the formula that we came up with, that we are going to do 1 plus max of the left and the right height. So we are returning -1 here, and what we are going to do is from here we are going to return 1 plus max of left height comma right height. Okay. And at the end of everything, we are going to return this height of the self root. So this is the call that we are doing on this. So now you see that we have written the very basic code that we kind of discussed during our algorithm. That is in this part, we have we had a root node, and but from the root node we cannot calculate it, so we went till the deep, the last node, and it is kind of a DFS that we did, and through which then we came from bottom to top. And how we came from bottom to top, this is the way in the code that we have written. And anyway, we are going to take this code and we are going to explore it completely. Before that, let's see how exactly we can test it. So for test, you can see there is this binary tree height code I have written. So this is the particular tree structure, and what we are going to do is we are going to define this tree in this manner and just write an assertion whether this tree height matches or not. So now I'm just going to, like, if you go to this testing section of the of your Visual Studio Code, this is the way you can actually test it out. And this is very helpful for any of the engineer who is trying to get better in the code. Keep on debugging alongside like your whiteboarding. This is also very important. So I'm going to just write this, and I'm going to just execute this, and you can see like this particular test have passed, where like where I'm trying to get the test the binary tree height, it is getting the height correctly. You can see over here the one passed in this whatever zero point 0.2 second, right? So now let's try to figure out what exactly has been our recursion methodology here. So let's explore for this particular tree structure that we took in our test case, how exactly the traversal is happening. So you can see like there is this two leaf nodes are there, and also for three is also a leaf node. So what would happen over here is, if I see the code clearly, at first the traversal will come from will definitely starts from 1. Okay, so after 1 it will at first come to the left height. Okay, so this particular line will be called. Once this line is called, again this definition of height get called. From there again it will come to the left height, so then it will come to 4, and from the 4 again it will try to go to the left of it. So here the game will start. If you see, the node is becoming none at this point of time, right? This doesn't have any node 4. So what would happen with the 4 is 4 will return -1. So if I start writing it, it will look something like this. At this end, 4 will be returning. Over here, 4 will be returning -1 from one of the node at its left. Similarly, after the left, it will also go to the right, and 4's right is also a null, right? So what would happen? The 4, the right of the 4 will also return another -1. So this is how our tree are being built. So for the 4 children of node 4, over here we can see as -1 and -1. Then the same will happen for the 5 as well. Okay, so for the 5 also the children will be the -1 -1, but let's go step by step. So at this particular stage, if you see, we are returning -1 in the from the both of the end of this, right? So both of this thing is returning -1, and what we have at 4 is the height here as -1 and this also as -1. Now at the level of 4, the height becomes 1 plus max of -1 and -1. So the height of the 4, as you can see, is 0. So now we are standing at this level where the height of the 4 is 0. So now you see the left tree of the 2 is now calculated. So right now this traversal is going on, you can see. So this guy has the left tree as calculated and it is coming as 0, right? So this part, the left tree for the 2, left tree height equal to 0 at 2. And now it got till this line, getting the left height. Now it will go to the right height. So what would be the what would be in the right height? In the right height, it will be again 0, because you see the similar kind of a traversal is only happening. Like if I see 5, 5 also have two node, one from here, like it doesn't have any children node, so it will have it will get returned -1 and -1 from here, and then at this level it will also be the same calculation, it will be 0. So what it will return over here is, it will again return the right subtree, the right tree height will be 0. So now over here we have the 2, and now 2 will be returning to 1. So at this level, this height is completely determined, like 2 has a height of 1, because what 2 will have, it is basically the max of 1 plus max of 0 comma 0, that is 1. So at this level 1 has its left tree traversed, and it is returning 1 as a height, right? And similarly, if we see after this stage of left height, we will see that we are taking it to the right height. So in the right height also, if we just see the calculation, it will, then the whole right traversal will happen, and the right traversal, it will return as 0. So at this level, at the level of 1, what exactly it is happening? It is happening the left height return as 1 and the right height return as 0. So with both of these things, now the calculation become really simple. It will become 1 plus max of 0 comma 1. So the height is becoming as 1 plus 1 equal to 2. Now if I go back to my Visual Studio Code, you will see over here that this is the exact test that we did. We tried to see whether the height is equal to 2 or not, and the assertion passed. So if you are like, this solution is completely available in the GitHub. I will put it into the description section, and I'd request you to debug it through. Like you can always run and debug. For example, this particular test, once you take the whole clone of the repository, this particular test, how you can run is, you can just write a debug test, and through it you will be able to see all the steps of the recursion. So once you explore the complete recursion, then only you will understand this height of the binary tree. And this particular problem is basis of many other medium and the hard level problem. So see you in the next video. I request you to clone the repository and just run it and understand the problem in more detail.